just to introduce, Isa's going to give a talk on a practical application, what SANDVIK are using big data for in mining operations. So Isa, over to you.
Yep. Thank you, Matt. Thank you, Laura, for a good presentation.
Can see your screen at the moment.
1 second. Yeah. Let me see if you see the full screen.
Yep, all good.
All right. Okay.
And I like that loader. Cool.
Oh yeah, my favorite too. Good. Yeah. My name is Esa Mattila. I'm representing SANDVIK Mining and Rock Technologies, and I'll give you an introduction how we enable big data and how we use big data in order to improve our customer equipment performance. So then, first few words about myself. So I'm 34 years old from Finland, the manager of global productivity and reliability centers. From education, I'm Master of Information Technology. I have worked 10 years in SANDVIK, and from these 10 years, 5 years with reliability and productivity related data science. I'm responsible for advanced data analytics, leveraging big data, and from commercial responsibility, I'm responsible for global remote monitoring service, which highly utilizes the big data. So the agenda for this presentation, I will give you a short introduction to SANDVIK Mining and Rock Technologies. First, we will look at the mining equipment maintenance strategy development roadmap and how data and big data fits into that development curve. Then I will talk about SANDVIK telemetry solutions for big data and smart maintenance. So these are the things which enables the big data. Then I will talk about SANDVIK remote monitoring service and how that leverages big data to enable smart maintenance for our customers. In the end, I will recap the cornerstones of big data-based smart maintenance, and then we have time for questions and answers. First of all, safety is a very high importance and definitely in our core culture of the company. So I want to remind everyone now to pay attention to the fire exits of the building where you reside. If you have need to wear protective equipment, please do so, and pay attention to the COVID restrictions as the situation in the world is what it is. Now, SANDVIK Mining and Rock Technology is part of a SANDVIK concern, which is a Swedish engineering powerhouse. We have 37,000 employees around the world. We operate in 160 different countries. We have 60 global R&D centers and 6,000 active patents. From this SANDVIK company or the corporation, I'm representing the SANDVIK Mining and Rock Solutions, which is bringing in 39% of the revenue and 46% of the profitability. And then when looking at the SANDVIK Mining and Rock Solutions product offering, and so basically our product offering is based on the fact that with this offering, individual can explore ore from the ground, and after exploring the ground, he can build up an infrastructure to extract that ore from the ground and cast it into a shape that it can be passed on to a smelter and cast it to a metal. Now, depending how deep in the ground the rock is, and the ore is, and which kind of rock it is surrounded by, that determines are we using underground drilling or surface drilling or mechanical cutting and so forth. Then I represent the parts and service organization, which provides parts and services to all these divisions, which resembles the certain kind of a product. Then, now before jumping into the big data, I want to talk about the maintenance strategy development roadmap. And so here we have 4 pillars of maintenance, and these pillars reflects to the type of maintenance what are used in mining equipment and usually in heavy equipment and basically in all equipment maintenance procedures. So we have a reactive maintenance. Reactive maintenance means that you only fix when something is broken. So in reactive maintenance, you're not using any intelligence in terms of instrumentations of data. Somebody could maybe ask him that is there any intelligence in it if you perform the maintenance in that manner? When there's a lot of breakdown cases, so things are led to fail before they fix, the overall equipment efficiency, meaning how well the machine is used based on how productive the equipment is measured from calendar time, is fairly low. The next stage is plant maintenance, and when plant maintenance takes place, at least certain parts of the maintenance actions are planned. So, for example, you change filters with a certain interval, you change certain wear parts with a certain interval, and so on. So the overall equipment efficiency increased when the nature of service is a bit more planned. Then the next step there is proactive maintenance. And when we start talking about a bit more complicated actuators and components like hydraulic pumps or engines and so on, the proactive maintenance is already considering instrumentation. So it performs a condition monitoring either on the machine, so understanding how the parameters are working or behaving before the maintenance plans are created. And then in proactive maintenance, we might also already use data. So in that sense, the data is measured and transmitted to a database or cloud solutions. And there is people who monitor the data and create the maintenance plans accordingly. However, in proactive maintenance, usually we are not talking about big data, and we are not, as per se, predicting anything. We are just observing the current values of the machines and actuators when the maintenance plans are formulated. Overall equipment efficiency can be fairly high, already up to 90% when proactive maintenance takes place. However, when we move to a predictive maintenance and we start applying advanced analytics, in addition that we observe what is the current situation of the machine in terms of health, we can predict how the health is going to endure, or how the health is going to progress. And how we're able to predict this is that we use big data. So with masses of data which being gathered over a long period of time, machine learning models can be built upon top of that big data sets. So harvesting right kind of a data from the big data sets and inputting the correct data sets to a machine learning model, the machine learning model is able to understand and predict into which direction the health of the equipment is going. And with this kind of a prediction, the maintenance planning can be extremely efficient, because the maintenance crew is already on top of the issues before they actually occur. And how do we get there? Now, few words about the enablers of big data and the telemetry offering of SANDVIK in general. So first of all, we have this brand called Nutrax. This Nutrax offers a different kind of sensoring solutions to our equipment. So there can be additional sensors added to the machine to measure certain kind of pheniniums or health or productivity related things. Also with this brand, we offer solutions for safety, so we can estimate the collision and avoid the collision avoidance. We can also expand the telemetry insights to the mine infrastructure. So, for example, measure the performance of ventilation systems or the infrastructure related things, so supply voltages and mine water pressures and so on. So these are kits which enables to measure things and visualize the things in a different kind of interface, where the customer can then do his own conclusions out of the data sets which is provided by these devices. Then the next year is an Optimine. With this product offering, we can this is quite a lot orientated to visualizing the mines and visualizing the processes of the mines. Also, it has capability to measure the health of the equipment. So these equipments, they provide very good visibility to the mine performance, and then allows the customer to do their conclusions and take actions to improve and identify the bottlenecks. And there's different kind of tools that you can then also salute tasks and kind of make the process more flexible and better. Then I could call this the highest tier. We have parts and service cloud-based solutions. So with this offering, we connect the machines to the cloud. And then these solutions are gathering the information what the machine produces and stores that to the big data big data cloud. We've been doing that for many years for thousands of machines. So we are starting having an enormous set of data, which help us to understand the performance of the equipment and the process of our customers. With these tools, the partner service tools, which is cloud-based system, we also provide these interfaces to customer where they can monitor their fleet and understand what is happening. It's very convenient to see the utilization and productivity of the equipment. However, when talking about building real understanding what is happening on the fleet and creating precise recommendations for the identified defects, there's a challenge. Even if you have very good interfaces and very good insights for your fleet, it's still fairly hard to really understand what is the actual defect and what would be the the appropriate and precise action item or recommendations to fix the issues. Therefore, we established this remote monitoring service, which is doing this what earlier mentioned, and also leveraging the masses of big data what we have gathered over the years with the thousands of mining equipments. Now, when we talk about, I'll put some pieces to the canvas. So the process of remote monitoring service, as mentioned, goes in a way that there is customer equipment. These customer equipments which operates in underground mines are then connected to internet. And when they reach out the access point, which is connected to internet, it captures the telemetry information from the machines and sends it to the cloud. On the cloud, there is AI models and different strong algorithms created from big data sets. I will come back to that soon. These Sentinel algorithms, if we may call them so, are monitoring if machine is having premature failure or if machine is having underperformance. So it's not producing enough tonnage what it should be, or drilled meters. And also these algorithms are monitoring the misuse cases of the equipment. So if the machines are not used in a way how they are designed to be used. Monitoring specialists, data scientists and data engineers, they observe this data and they create new algorithms and use the existing algorithms to pass on the recommendations then to the contact person on the mine site. This contact person is then handling over the recommendations which are either related to the maintenance, so predictive maintenance recommendations to take action so that the breakdown of the machine can be evaded, or they are operator-related insights. So there can be reports which describes how the certain operators are performing, how they are using the machines, and what they should be doing differently. And these two recommendation or the information related to recommendations, the action items are then naturally carried out to the customer maintenance team, who will then carry out these maintenance related things to inspect and eliminate the defects which been identified as at the moment, or the predicted premature failure cases which are going to happen in the near future. And then the operator related things, they are provided then to the customer operator teams. So we want to highlight that which operators are performing the best, which one are having most issues, and which kind of use cases. So for example, driving downhill with inappropriate gears, or entering the muck pile with a loader with the appropriate procedures, or drilling with the improper drilling parameters. And then the loop goes on. So the recommendations are created, feedback is going back to the monitoring center, and then this circle just keeps going, matures and improves the performance of the fleet. Now then, how this is related to big data is these recommendations and the algorithms which are created provide these insights. They are built with the big data sets what the SANDVIK possesses. So we have thousands of mining equipments for many years. We have harvested massive cloud. We have data lakes and data warehouses where the information is stored. together with the monitoring specialist, data scientists, and data engineers, who then collaborate with the equipment, or the engineers who design the equipment, or the service technicians who are maintaining the equipment. They do the big data discoveries together, and with these discoveries, we either create algorithms to identify the misuse of the machine, or defects, and most importantly, we validate the training data sets, which are then given out to the machine learning model and neural networks. A little bit more about the neural networks. So it's important to have a lot of data for the neural network or machine learning model, that it understands what is right and what is wrong. So the training is basically based on the things you could consider like small children, who you tell that this is right and this is wrong. And when he goes further, he then understands that this is the right decisions and this is the wrong decisions. And basically the machine learning model does the same. You teach him what is right and what is wrong, and then the machine learning model, AI model, is in the cloud and observing the signals which are coming from the machine which is operating. And based on the observed signals, it can understand that is this trending now to an unhealthy direction, or is things okay. And a very important thing when building up the machine learning models and AI models is that it's not only about big amount of data. It's definitely that you give him right data sets for right use case. And then in order to understand what is what data sets definitely correlates with certain kind of failure mode, you need to combine a lot of telemetry data, oil analysis data, maintenance data, well, basically a lot of different data sets together, and consolidate the findings with the OEM knowledge experts. And if those OEM knowledge experts happens to be the guys who have designed the machine, then definitely that's those are the best guys to answer the questions. And in this manner, when the process takes place, it will definitely improve the utilization of the customer fleet. So there will be less unplanned maintenance, and from process perspective, the identified bottlenecks can be eliminated, which increases the utilization of the machine. As well, the breakdown cases are decreased by identifying the premature failures, and most importantly, the correct usage of the machines is ensured. The less problems and issues and failures will decrease, which naturally will decrease the cost per hours for the equipment. And as an OEM, SANDVIK is in a very, I would say, unique position that we hold a massive amount of big data, and we have a very strong network of data expertise inside the company, because SANDVIK has been investing data science and associated resources for many years already. And we are also the people who designs the machine, so we know them through and through. And this combination of knowledge and the big data enables to create precise and healthy machine learning models and processes. Then kind of highlighting I put here a few, I would say, cornerstones for big data-based smart maintenance service. So when you leverage the big data, you basically monitor the big data sets or the data sets which are produced by the customer fleet. You will continuously be up to date what is happening, and based on the findings and the existing algorithms, you can create predictive and preventive maintenance recommendations. Maybe we can categorize them in a way that predictive maintenance recommendations are more critical and ad hoc by nature. So then you make sure that the catastrophic failure is not occurring when you already have an understanding what's going to happen in the near future. Preventive maintenance recommendations, so leveraging the big data and the data sets, you are able to give planned maintenance recommendations which are based on identified defects. Then continuously measure the performance of the operators, not only the productivity, but also how the machines are used. Now this is important, because if you're able to precisely predict that the engine is failing, for example, every 1,000 hours, that's nice. you know when it's going to be failed, so you can plan your maintenance schedules accordingly. But the fact is that the engine is still failing every 1,000 hours when it should be lasting 15,000 engine hours. So in these cases, very often it highly affects how the machines are operated. And when you improve how the machines are used, so you eliminate the misuse of the machine, you naturally also increase the safety, because the safety violations and lost time injuries are very often related to the misuse of the equipment. All the information and the reports and action items which are provided are based on measured data, so it's more factual instead of being more subjective. Maybe a consolidated example would be an root cause reporting. So there is root cause reporting which is not using any data, or in some cases not even any instrumentation. So you might have seen these reports where there is a destroyed axle or a pump or an engine, and there is some scratches on the side of it, or some bolt has jinxed. If the person who is doing the root cause reporting is not very familiar or super expert on the similar failures, they tend to be a little bit subjective. So there is few pictures and bit of a story what probably happened. But when you measure the right things, when you do a root cause reporting, you can from the parameters measure how the certain parameters of the actuator was trending, which gives you way better understanding what really was happening. And most importantly, you also understand how the machine was used, which affected to that that failure. With this big data-based smart maintenance service, we constantly track the performance of the fleet. And when something, for example, if we measure MTBF, we see that the MTBF is positively trending, and when it starts to suddenly decline for certain reason, we can then deep dive to the facts of the data and understand what was the issue, and based on those findings, create action plans to evade this problem in the future. Also, when company possesses a big data set from multiple machines and customers, it allows to do benchmarking, so you can measure how well customers mine X is performing compared to customers mine U or so on. So it allows you the customer to have reporting of understanding how their different mines are performing, how much they have a utilization or fuel burn or extensive idling. In some cases, it can also be anonymized and compared against the other customers, but in those cases, definitely no customer names and so on are not exposed. Talking of that, we don't either use any names of individuals, so everything is anonymized and just grouped by the shifts and so on. So to make sure that there's no violations on GDPR policies. And maybe one important thing, that aggregating masses of data to a right shape with strong performance and low response time is it's challenging. It's still with nowadays technologies is fairly doable, but really understanding from the data what is the actual phenomenon, that's even the more challenging part. But having said that, it's far from being impossible. It just requires a certain correct kind of an individuals and a good team and strong collaboration between different stakeholders of the companies. I think I went this fairly fast, so we probably have quite a bit time for questions and answers. So
no, it's fine. I've got a little bit of a wrap up as well, Lisa. So that's really good. That's great. So I think what's probably good, that was two interesting talks there. I was just what I'll probably do is I'll pass over to Steph to field some questions at the moment, and then after the questions for the speakers, I'll do a few slides and a wrap up at the end, and just discuss on how we can get involved with Deep Digital Cornwall and maybe assist businesses moving forward. So Steph, do you want to target some questions?
Yeah, perfect. Thank you, Laura. Thank you, Issa, again for 2 excellent talks. Thanks for that. I've got a question for Laura here. Is big data science the future? I believe AI and machine learning is saturated. Is that true? Laura?
Laura, you're on mute.
I'll unmute.
There we
Can
go.
you hear me now? Right,
Yeah.
cool. Okay. I must have been auto-muted while Issa was nattering, which is fine. Yeah. Okay. Where are we? Is big data science the future? I believe AI machine learning is saturated. Okay, let's unpick it. There's a couple of questions there. Data science and understanding data is going to go hand in hand with machine learning, because practically the only way of really getting to grips with the amount of data that's being generated is autonomously. A human can't process the amount of data that's just being generated and captured. So I don't think AI ML is saturated. There's definitely a future for it. And it is going to go hand in hand with big data. I mean, now this data has been captured. I just cannot see people, at least in the short, medium, long term, well, yeah, short, medium term, just going, do you know what? We're just not going to bother with big data. You look at the likes of, I don't want to mention a particular country, but there are certain countries in the world which are automatically gathering a heck of a lot of data to manage their new cities and things like this. And it's, yeah, I can't see it. It won't end. Yeah. What might happen is a recasting of big data. You know, after a while, I mean, this is a little bit of a laughable example, but after a while, Facebook will have more than enough photos of fluffy little kittens. Yeah, they will start to offline data and then eventually throw it away. Well, I'm assuming they will. It depends. You know, it just depends on how much storage space they have and whether they're willing to keep buying it. You know, I don't know, does that answer the question?
Thanks, Laura. I think so. And that goes on to the next question, which is slightly related. Where do you think big data is going? Will PCs always be able to cope? Will they be able to manage? Will they be able to get bigger, for example?
Okay. Yeah, I think the uptake of big data will carry on. Now, will PCs get bigger? Well, there's a classic Moore's law. Moore's law sort of like predicts a doubling of computing power every X years. I can't remember off the top of my head. And so far, it's been pretty accurate. It had a bit of a bump, but then NVIDIA basically developed their graphics processor units, GPU processors, and that unstuck the logjam on the processing power. But the real key for big data is one computer can't process it, and it's not the issue of the size of an individual computer. The issue is how many computers can we connect to solve the problem. So what you'll find nowadays is the computers that people call supercomputers aren't actually a single computer. It's just a heck of a lot of them, thousands, tens of thousands of computers just connected over a network and potentially storage network, which all run in parallel. So the key to it is the development of software systems that can operate in parallel. So it's the parallel processing architectures which is the key to scaling with the amount of data. I mean, and yeah, so an individual PC will not be able to keep up, but that's not a problem, because basically we can go and we can buy cheap PCs and stack them all together and make what they either call a Beowulf cluster or a grid computer, or you name it, under loads of different names. There's just lots of little computers all doing their little problem, and somebody else assembling all the little solutions into the big solution. So there we go. Does that answer that one?
That does. Thank you, Laura. That's it for your questions. Thank you. I've got a question for Issa here. What value has SANDVIK gained from using big data, and what impact has this had for the mine in terms of value?
Yep. Well, thanks for the question. So, well, the main value is that by using big data and measuring things, it brings visibility. So it brings visibility how the customer process is working, which part is not working, and as well it gives visibility for SANDVIK how their machines is being used and how they are performing. So this foundation of measuring things is the basis of improving things. And then when these improvements are casted in a form as a service, then the benefits what the customer have got from this is that, for example, with one customer, in 1 year time we decreased the MDPFs with 40%, and a fleet of 7 trucks compared to the similar time without this kind of a big data based service. With the service, the fleet was able to achieve 4,500 engine hours more. And when that is converted to a production, it's and if we would think that the commodity is gold, which it was in this case, we're talking about a massive numbers. But the main thing what the data brings is visibility and ways to measure what is happening, and that's the basis of improving things.
Perfect, thank you. I've got one more for you, Issa. Is there use for big data in machine failure in mine site maintenance of minerals processing, for example? So as you described, but a different technology, different use.
We've been, as per our portfolio, we've been focusing on loaders, trucks, and rails. So we haven't, or maybe if you can specify a little bit more that what do we mean with mineral processing? Is that the part where the rocks or the ore is melted to a metal ore?
Yeah.
So I'm not aware, but I would highly suspect that the companies who are manufacturing those process lines are also leveraging big data and advanced analytics. So at least I hope so.
Okay, perfect. No, thanks for that. Yeah, it's a bit of not your background, but yeah, it seems like there could be synonyms there with that. Yep.
Maybe a quick comment on that. So basically thinking about this fixed plant processes. So if there's no or the affection of operators is basically a little bit lower because the process is fixed. It should be theoretically easier to identify premature failures and improve the maintenance things, because the human factor is less, or should be less, present on the overall process.
Perfect. Thank you both again. That rounds up the questions. Unless anybody else has any more they'd like to quickly pop in the chat, we can hand back to Matt.
Yeah. Okay. No worries. So yeah, 2 really interesting talks, and yeah, if we've got any follow-up questions, we can always direct them later on as well if we need to. I'm just going to talk a little bit now about well, where we can help from DDC in terms of SME business assists as part of the remit of Deep Digital Cornwall. So business assist, a business assist is a bit of a jargon, really, and I'll just break it down here. Basically, it's us and the employees of the centre and also the wider staff which are signed in time are there available to SMEs in order to help with business assists. So a business assist is conventionally a 12-hour assist. It'll start off with a business eligibility check at the start. So basically, You guys will send out some documentation, and the SME can fill out that documentation, and we'll make sure that they're eligible to be into the fund. Basically, you need to be an SME which has got a significant interest in Cornwall and the Isles of Scilly in order to be part of the fund, because it's a regional targeted funding campaign from ERDF. Following that, we'll probably have an initial meeting and a chat about the problem definition you've got and some scoping, and then from there we can allocate different staffing and team allocation. This can be, you know, internally within the CSM staff, or alongside some of the impact fellows. For example, if you've got a big data problem or something, then we would probably target this one at Laura. And potentially the Institute of Data Science can be involved depending on the application. Then we'll tackle the problem, and then there's an option for exploring additional support and ongoing assistance. So I mentioned earlier that there is £750,000 worth of funding which is available to SMEs. For example, if as an SME you want some more computing infrastructure in order to adopt big data into your business, or you're interested in as a business that the offerings from different commercial partners, and this is going to enhance your business growth, then you can apply for this funding through us, and then take your business forward the way you want to go through from that. So we really want to engage with as many businesses as possible. And fundamentally, we just want to build growth in digital technologies and assist companies from a technical perspective. And the long-term sort of ambitions of the university is to build deeper relationships with those companies and look at ongoing collaboration. So we can look at the grant fund as one thing, but if there's a much bigger thing we want to tackle, then we could, you know, together apply for some research funding money in order to build a longer project for, you know, several years if needed be, or various other aspects. There's a QR code on the top of this slide. That is to the brochure of Deep Digital Cornwall, and it's got some of the you know, principal research aims of the project, and then also how we will interact, and it's got a breakdown. So obviously these slides are only a quick overview, but if you go to that QR code, download the brochure, it will give you a lot more information. And then finally, just a few contact points for Deep Digital Cornwall. So the website is at the top. Then we've got the group email address if you want to get hold of us in any way. There's LinkedIn accounts, Twitter accounts, and the Eventbrite as well. One thing to also plug is that we're going to run a number of machine learning research rooms coming up now. So now we've got the idea of big data, we can go into a little bit about ML and how ML will complement big data. And we start them on the 15th of June, and they will run until the 13th of July. Again, another QR code there if you want to go to the Eventbrite and register for those sessions. That'd be really good. But that basically, unless there's questions from the floor or anything else, that'll bring the big data event to the end. And I would really like to thank the speakers for their contribution. It was really good. It's obviously quite tricky with Zoom for everybody to clap, but I hope everybody appreciated that effort, and well done.